Welcome. This is my presentation on pre-engineering projects. And these are just mini projects that contain engineering concepts that can be fit into a STEM curriculum. So now the purpose of this project was to create these projects for an elective that I had in mind that would be like a pre-engineering course that would fit all different types of STEM components into it. And so each of these projects really has engineering concepts in mind. So coding, 3D printing, robots. So anything to get our students exposure to these elements that they wouldn't necessarily have in an ordinary math or science classroom. These projects are also going to be backed up or are going to help inform a curriculum that can hopefully be carried out to create this pre-engineering course in my school right now. So throughout my project, I tried to hit several of the NETS standards. So a few of them are that students leverage technology to take an active role in choosing, achieving, and demonstrating competency in their learning goals informed by the learning standards, learning sciences. So because students are going to be coding and doing 3D printing and using robots, they are using this technology and they're choosing how they want to use the technology to further their understanding on a certain concept. Another standard that you'll see in some of these projects is this one right here, where students are using these resources to construct knowledge and to create more of a meaning in some of these concepts. And they're doing this by producing artifacts that are going to help make these learning experiences more meaningful. Students are also going to be developing better problem-solving skills and technological methods that's going to help them develop and test different solutions. And again, I'll show you that in some of the projects. As far as teacher standards, some of the standards you're going to see that my role will be during these projects is to facilitate and inspire students' learning and creativity. So really giving them the freedom and opportunity to choose the resources they want to choose the content they want to build upon, and make something from that. And then also design and develop digital age learning experiences and assessments. So my school uses Schoology as their platform. So this is where I've hosted all of the materials, all the different projects. And so each folder represents a different project. So for instance, this first one, coding using Scratch. Each component, we have an introduction here, so it shows students how to make an account for Scratch. This is a little video that I created so that to get students started with Scratch, because this is going to be the first time for a lot of our students that they've seen coding. So if we come back to here, or back to the coding using Scratch, here's all the project information. So it tells exactly how to get started, what the task is, and then they can click on the attachment to see the rubric. I've also attached the rubric and all the information down here. It's just a page. And so we'll open that and you'll see here is the rubric. So each project has a different rubric that is created specifically for that project. In each of the projects, I've also created a discussion forum that students can use while they're trying to collaborate on the projects. So they can use this to correspond with one another, or maybe do a peer review with one another, post any of their work. And that discussion board is utilized in every single one of the projects. And then finally, at the end of each project, I'd like students to do a short reflection. Maybe that's through a video, maybe that's through a paper. I want them to include items like what they learned, what they liked, disliked, how they have done it differently, what are some of the obstacles they overcame, and how did they do that. So just something so I can see what they've gotten out of it, and also so they can self-reflect and really think about what they've gotten out of this project. Now I'll go through a quick review of all the different projects. This one's going to be coding using Python, so a different language. And in the previous one, we had them creating a physics calculator. In the Python, they'll be creating more of a pre-calc calculator. Then the 3D printing in physics. So in this one, they're allowed to choose any one of the topics we've done in physics and try to create something out of it. 3D printing conic sections. So once again, this is a specific project for our conic section unit. So they're going to design a cone so that when they can take it apart, it represents all 4 conic sections: the circle, parabola, hyperbola, and ellipse. And then we have our Makey game controller. So in this specific game, they are going to create a video game using their Scratch account, and then they're going to use the Makey equipment to actually make their own game controller that will hook up to their game on Scratch. So this is very open-ended. They'll be able to kind of create any game they want, use any type of controller to help them get through that. Then we have Sparky Beats an Obstacle Course. So this is the Sparky robot, and students are going to be creating an obstacle course either around the classroom or in another environment, and they have to program Sparky so that it can get through that certain obstacle course. And then finally we have our Arduino projects, and this is really the most open-ended one. They can go to any of these projects and choose what direction they'd like to go in. And for this one, because it's so open-ended, they're doing a lot of the proposals and creating a list of the tools and resources and creating their own timeline and rubric and assessment. So this puts a lot more of the emphasis on their own active learning. And lastly, these are all of the references that I use to do my literature review and to create some of these engineering projects. Thanks very much.